Dr. Vijay Lakshmi is working as a professor in the Department of ECE, Anna University, Chennai. She has more than 17 years of experience in teaching. She has published more than 90 papers in international and national journals and conferences. She has organized more than 10 workshops and has attended more than 40 workshops and seminars. She has guided more than 100 projects in both UG and PG level. She is supervising 14 research scholars. She has established an AICTE sponsored MODROB project for VLSI Lab. She has an endowment award for the top rank holder in PG degree and has 4 cash awards for producing cent percentage of result in Anna University curriculum. She is a life member in various professional bodies like ISTE and IETE. She has specialized in mobile communication, microprocessor and microcontroller, digital system, computer networking, and neural networks.
Welcome to UGC lecture series, BSc Electronics Honors, Electronics Practicals 9, Microprocessor Programming. In today's episode, we will discuss about sorting of n numbers. That is, we are arranging the numbers in either ascending order or in descending order. In case of ascending order, how to find the logic to generate the ascending number? So, we have a n numbers, right? So, among the n number, first we have to find the smallest number among the n. Then we have to pick it and keep it in one location. Then n minus 1 numbers are compared. Among that, we have to take the second smallest number. So, in that way we are comparing till the n, that is one logic. Or in another logic, we are selecting the greatest number, then keeping in the last location, that is pushing back. So, in that way also we can arrange the numbers. So, first I will explain the ascending order. So, for the ascending order I have taken the 5 numbers 0, 7, 25, 13, 48 and 5. So, among that, as per microprocessor programming, or simply you can take a logic what is behind the ascending order. So, I will take the first number 17, the second number 25. So, these two numbers are compared. So, in microprocessor we are depends on the carry flag. When the carry flag is set means the accumulator content is lesser than the memory content. Okay. When the carry flag is set, then the accumulator content is small. Now, we are concentrating about the ascending order. So, the accumulator number is small. So, leave it. Now, this accumulator content is compared with the another memory location. So, the first number is smaller than the second number. So, first number now compared with the third number. So, now also the first number is smaller. So, again I will compare the first number with the third number, or first number with the fourth number. So, now the first number is smaller. So, I will keep that same value and comparing with the last number. So, now rearrange the values as 0, 5, 25, 1, 3, 48 and 0, 7. So, when the carry flag is set represents accumulated value is smaller. So, I will continue a call with the next number and comparing the process. Suppose the carry flag is reset means I was swapping the two numbers. Now, 5 and 7 is swapped. So, one cycle is over, which represents the first smallest number has found. Now, I left the first address, I will take the only 4 address. So, among the 4 now I have to find which is the smallest. So, now I have the first data as 25, 25 is compared with 13. So, what will happen? Now, the carry flag is not set, that is reset. So, we have to swap the number. So, first it become 13, this is 25. Actually, the first value is higher than the second value. So, we are interchanging the value. So, now I have the 13. So, this 13 which is in the accumulator is compared with the 48, now which is lesser. the accumulated value is lesser than the 48. So, I will continue with the next number. Now, 13 and 7 is compared. Now, we have to swap it because the value is reset. So, after that what I have, the order is, the first value is 0 5, leave it. So, now the new value 0 7, then 25, 48, 13 is available, right. So, now second smallest number is found or find. Now, we have to compare the remaining 3 address. So, among the 3 address, so first data I have take it as 25, the 25 is compared with 48, right. So, now carry is set, which represents the 25 is smaller than the 48. So, now I call the next number, which is 13. Now, compare 25 and 13. Now, carry flag is reset. Once the carry flag is reset, I have to swap the data. So, after swapping, what I have 0 5, 0 7, 13, 48, 25. Okay. So, the third cycle is over, which represents 3 smallest number has arranged. Now, I have the number which is 48 in the first number. Now, 48 and 25 is compared. So, after comparing, what is the value? Now, the carry flag is reset. Once the carry flag is reset, you interchange the number. Now, it become 25 and 48. In the next step, we have arranged all the numbers. So, when we have a n numbers, we are rotating the loop only n minus 1 time. So, based on that, you can initialize the counter. Okay. Now, I think you get the idea how to arrange the numbers in ascending order. So, we have n numbers, or here in this example 5 numbers. I take first number compared with the next number. When it is smaller, I leave it. I will call the next number and compare it. So, till meet the condition I will continue. When the condition is failure, that is my data is higher than the memory data or comparing data. So, that time I have to swap the data. So, in the first cycle only the last condition is failure. So, I have swapped the 5 and 7. So, and also it exit from the loop, it indicates once it exit the loop or the counter reach 0, it indicates one of the smallest number has finalized. So, that is arranged in the location, right. So, now remaining 4, among the 4 I have to find the smallest and arrange it as the second. Then I have only 3, among the 3 I have to find the smallest number. So, that will arranged, then remaining 2, if it is a smaller, then leave it, otherwise swap it. So, this is the logic. First we have to initialize the one counter which is called the data continuously, right. The first data with the second data with third data. So, one counter we need. Another counter is required which is to arrange the numbers in ascending order. Okay. That is, one is represents how many smallest number is there, one is represents how many numbers in the sequence. So, based on that I have planned to write the program for ascending order. So, in the ascending order the carry flag should be set. If it is set, the accumulated content is lesser memory. So, I have go with JC. So, how to start the program? So, always we have to start the program with initialization, right. So, I will initialize the location that is memory location LXI H comma 4500. Okay. So, after that I have to initialize the counter. If you have a 5 numbers, just you initialize it as a 4. Then I need a 2 counter, right. So, I will store the same value in one of the temporary register. Now, go to the logic. So, for comparison one of the data should be in accumulator. So, I have moved the first data to accumulator, then I have to compare with the next data. I have increased the memory location INXH. So, now I am in 4501, right. I have a location 4500, 501. 502, 503, 4504. In each I have a data as 07, 25, 13, 1805, right. I have increased the location, right, INXH. So, now I am in 25. So, what I have to do? One of the data in accumulator, another data in memory. So, compare the accumulator with memory. So, the memory data is compared with the accumulator. Then what I have to do? I have to check whether the carry is set or not. If carry sets, then you can continue the process. Continue the process which represents decrease the counter. Decrease the C counter, then the process will repeat till the counter reach 0. Okay. Suppose if carry is set, that is not set, then what we have to do? Swap the data, that is simply by interchanging the accumulator content with memory content. So, for that I will take one of the temporary register D, which is unused register we have to take. So, move D comma A, then move A comma M, then move M comma D. Okay. So, by using that, now I have swapped and arranged. So, once it exits from this loop, it indicates one of the smallest number has found. So, after finding one of the data, now we have to store the data to the location. So, here I have planned to store the data in the first location, which is in the 4500. So, after exiting from the loop, now where I am? I am in 4504, but I want to store the data in 4500. So, what I have to do? I have to decrease the memory location. So, how many times I have to decrease? Based on the counter value, right. So, I will initialize the counter value in one of the temporary register, move E comma B. So, the B value 04 will move to the E register. Now, use DCXH, okay. DCXH, DC or B, then jump on no 0 to here, right. So, just I am decreasing from 4 to 3, 3 to 2, 2 to 1, 1 to 0. So, now I reach the location 4500. So, after reaching that, what I have to do? I have to store the data. So, where I have the data? I have kept only the smallest number in accumulator. So, that data to be loaded in the memory. So, move M comma A. So, now my data is arranged in the memory represents 4500. Now, what I have to do? I have to increase the location INXH, then decrease DC or B. Now, only the counter is reduced. Okay. So, then I have to repeat this till reaching the 0. To where I have to jump? Here I have to jump. Okay. Once it exits from the loop, it represents the 4 numbers are compared, then you stop the program and take the result in 4500 and store it. So, once again I will explain this logic. So, I have used LXI H comma 4500, which is to initialize the memory location, then MVI B comma 04, which is to limit the number of values. Okay. It is like a counter. Then we need a 2 counter for writing ascending order program. One is for finding the smallest number, another one for how many times based on the numbers. So, move C comma B, then move A comma M, first data is moved, then increase the location, compare. If carry sets, it represents accumulated data is very small. So, you can call the next data and compare it. So, instead of calling, I decrease the counter, then increasing, then comparing. So, increasing and comparing with the reduction of the counter value, I will continue. Okay. If carry is not set, that is reset. Reset means it will enter into this instructions, which indicates the two data to be swapping. Okay. So, in this program, so when we will get reset only at the last term, so the 05 will become here, 07 is here in the first cycle. In the second cycle, after that we are shorting the number, so reduced to 4. So, now this 05 is moved into the memory, then increase the location which is 4501, then decrease the counter as 3, it is not 0, now the 3 value is moved to counter. Now, what is the memory value? 15, 25. This 25 is moved to accumulator, increase the location 13, then compare with the 13 and 25. If carry is reset, then you swap the data. So, this become 13, this become 25, right. So, now I have the 13 in accumulator, the 13 is compared with the 48, it is a set value. So, I will call the next number which is 05 by increasing the location, this process will repeat. So, now 13 and 7 will compare. So, after comparing that, now the carry flag is reset. Reset means we have to enter into this, interchange the value. Now, you get 07 here, 13 here, right. So, now decrease the location. What is the B value? B value was only 3. So, 3 times I will reduce the 07 will return into 4501. Then after that increase the location and decrease the counter, come to here. So, the 2 value which is moved to the accumulator, increase the location, and the same process will be repeated for the remaining numbers. This is a way to arrange the number in ascending order. So, one more logic to write the ascending order, they were planning to set pushing the largest number into the last, automatically you will get the smallest number in the memory. So, in that way, so they were comparing this 5 1 7. So, 07 is smaller number, right. So, leave it. I have to push the greatest number in there. Okay. So, now 7 and 33 is compared, the same carry flag set, right. It is not set. So, I will take then 18 and 7 is compared, it will continue, then 7 with compare. So, I have to swap the data. So, after completing the first cycle, now the order is 05, 25, 33, 18 and 07. So, now I will skip this, only among the 4 numbers I have to compare it. So, among the 4 number, so now the 25 is compared with 33, right. So, after comparing 25 and 33 is no need because carry is set. Now, the 25 and 33 is compared, so it will be swapped, right. So, the 18 and 25 is interchanged. So, 18 and 25 we have. Now, I have the data in 18 which is in accumulator, that data is compared with the next value which is 07. Now, the carry flag is reset, again we have to interchange the value, right. The 07 and 18 will interchange. So, finally, what you get 07, 33, 25 and 18. Okay. So, this is the second cycle. In the second cycles, next smallest number has finalized. So, now we have to proceed with the remaining numbers. So, in the remaining number, first I have the number 33, the 33 is compared with the 25. So, now what is my aim? Smallest number to be front, alright. So, this 33, now carry is reset. So, I interchange the data 25 and 33. So, now the 25 is compared with the 18, right. So, what will happen? The carry is set. So, the 18 and 23 to be interchanged. So, 18, 33 in normal, that is in middle location, 25. So, now counter reach 0, which indicates the cycle is over. Now, you have a smallest number in accumulator. So, that data to be stored in the memory. So, among the two I have to find the smallest number. So, I have a 33. another number is 25 compared, okay. So, after comparing what will happen? The carry flag is reset. So, it indicates accumulated value is higher than the second value. So, second value comes to, I have to bring it to accumulator. So, interchange the data 25 and 33. Now, exit the loop. Now, check it in the first cycle, the first smallest number among the n number is stored. In the second cycle, I have selected the next smallest number and stored in the second location. In the third cycle, okay, the next smallest number 18 is identified and stored in the third location. In the fourth cycle, only 2 numbers, that is at the end cycle. The 2 numbers only swapping or leaving as it is. That is why I ask for storing 5 numbers or for sorting 5 number, we have to use n minus 1 loops, because no need to rotate the last 2 numbers for 1 loop. So, for sorting 5 numbers, you initialize the counter value as 04. So, I will write the program for this logic. MVI C comma 04, then move temporarily storing this to another counter, then initialize the memory location LXI H comma 4500, then move first data to accumulator, then increase the location, then compare the next data. Okay. If carry set, suppose I have write it as star here. So, here I will write. So, here if no carry means decrease the B register value, okay. Then jump on no 0 to move the location. Once if carry is not set, then what we have to do? We have to interchange the data, that is swapping. So, move D comma M, then move M comma A, then move A comma D. So, during that time I want to store the smallest number in the previous location, right. So, for that I decrease the location DCXH, then storing the data, move M comma A, okay. Then I use INX H. So, what I have done, I have interchanged the data and replacing to the same location also. That is why decrease the location and store the accumulated data into memory and increase the location. So, once after completing this, I have sorted first number. So, then what I have to do? I have to do the main counter reduction DC or C. So, this has to rotate from the starting. So, what it represents, every time we are decreasing the counter and initializing, now I will check which is the smallest number. So, the smallest number will compare with another number. If it is set, it represents we have a smallest number in accumulator, otherwise call, that is if the accumulated value is smaller, then we call the next number and compare it, right. If the carry flag is reset, represents the accumulated value is higher than the next number. So, we want only the smallest number in accumulator. So, we have to do the swapping. So, based on this we can convert this program into opcode and execute it, you get the sorting of the numbers. Suppose now we have written the program for ascending order, right. If you want to write the program in descending order, just you change JC by JNC without change anything, only here, because we are checking the carry flag set, accumulated value is smaller. So, in that way we are keeping and continuing the process, we get smallest numbers, that is ascending order. Suppose you want to keep accumulated values higher, then we have to use jump on no carry. In the jump on no carry, it represents the accumulated value is higher, higher, higher. So, in that way we are keeping the highest number first, then next highest, next highest. So, this way we can arrange the number in descending order. So, let me check the execution of this program. So, now I will execute the descending order program for 8 numbers by selecting the location 4300. So, in 300 first I have to give 0E, then 04, 41, 21, resultant address 0, 45. Then 7E, 23, BE, D2, right, jump and no carry, D2, 1 2, 4 3, then 5 6, 7 7, 7A, 2B, 7 7, 2 3, 0 5, C2, 0 6, 43, 0D, C2, 0 2, 43, 76. So, before executing give the input 4500. So, it should be descending order. So, you give any number in this order. So, 5, 2, 8, 7, 4, 6, 3, 1, 9, then 1. Okay. So, now reset, go 4300, execute, reset, take the resultant address 4500, check the result, maximum number 9, then 8, 7, 6, 5, 4, 3, 2 and 1. Okay. So, this is the way I have written the program for 8 numbers to arrange the number in descending order. So, now I will execute the ascending order program, which is taken as 5 numbers. So, initialized in the location 4200. So, I will type the program sub 4200, I take it as. So, MBIC 0E, then 0 5. So, for 5 numbers I initialized n minus 1 counter, so 0 4, then move the value into temporary in the register 41, then LXI H 21, 0 42, then move A comma M 7E 23, compare BE DA, if carries occur then move to the location 12. So, 1 to 45, otherwise we have to swap it. So, 56 77, 7A, 2B, 77, 23, 05, C2, 06, 45, 0D, C2, 02, 45, 76. So, before executing the program, check it once again, 0E 04, 41, 21, 0, 42, 7E 23, BE DA 1 to 45, then 56 77, 7A, 2B 77, 23, 05, C2 06 45 0 D C2 4576. So, before executing, this is ascending order program, right? So, we have to give the input. I have selected the address to type the program is 4200. So, I have to generate the resultant in 4500. So, here I will give it as 45. So, before executing the program, you take the source address 4500. So, we may give any number. For simple I will give 0 1 5 3 2 and 4. Okay. So, we are expecting the output as 0 1 2 3 4 5. So, go 4200 execute. So, now take the resultant address 4500, give the input 0 1 0 5 0 3 0 2 0 4. Okay. So, go 4200 execute, reset, take the same address. We are expecting the number 1 to 5 in ascending order. So, number 1 2 3 4 and 5. Okay. So, this is the way we are arranging the number in ascending order. Summary of the episode today. So, in today's episode we have discussed how to arrange the numbers in ascending order and descending order. So, for the ascending order, first we have to know how to select the smallest number among the n. Okay. So, once if you have selected, then you keep it in another location, remaining n minus 1 number is compared, then select the smallest number, then n minus 2 is compared, n minus 3, n minus 4. In such a way we are comparing and selecting the smallest number and keeping one more in memory locations to arrange the numbers in ascending order. For the descending order, we have to keep the greatest number. Okay. So, first we have to know how to select the greatest number. After selecting the greatest number, you keep in one buffer, then among the n minus 1 you select the greatest number, then keep it in the another rack. So, in that way we are continuing. Okay. So, we have discussed only the arrange, that is a sorting number for ascending order and descending order. Questions: write a program to find smallest number among 4 numbers. When carry flag is set, what is the comparison result? That is either accumulator and memory. You have to put either greater or lesser symbol. How to initialize 2 counters in ascending order. Thank you.